So just to summarize the embryology, so initially we have two layers, that is epiblast and then hypoblast. Then a primitive pit is forming on the epiblast through which the multiple cells are migrating interiorly, displacing the hypoblast, which will form the endoderm. Then the cells are migrating further, leading to formation of mesoderm, and the mesodermal tissue will lead to formation of the notochord, and until this stage formation of three cell layers and notochord is called as gastrulation. After that one, the notochord will influence the overlying ectoderm to form the neurectoderm, which will invaginate, forming the neural tube, and then it will detach to form proper neural tube, and in between the space will be occupied by the mesodermal cells. So this primary neurulation will lead to formation of the proximal portions, whereas the distal portions will be formed by secondary neurulation and retrograde differentiation. So this will be formed by appearance of a caudal cell mass, which is basically a totipotent stem cells which can transform themselves into any of the components. So they will lead to cavitation, and ultimately they will attach to the already existing primary neurulation components, leading to completion of the components. Now, so instead of looking at the open and closed dystrophisms, we can try to see whether they are anomalies of gastrulation or primary neurulation or secondary neurulation or combined anomalies of all these components. Just for understanding, I'll try to show you this particular slide again. This is extremely important. As I told you previously also, the step which is forming from this stage to this stage is the most important step. So here we are having the invagination of the neural tube, and here we are having proper detachment of the neural tube, and in between space filled by the mesodermal cells. So this is the most important step, and these two functions like detaching the neural tube and its closure and the closure of the overlying ectoderm, this should happen in a very coordinated manner. If it doesn't happen properly, so there will be some disorders of primary neurulation. This is called as non-disjunction, where the neural tube is not detaching itself from the overlying ectoderm. Now what will happen? Because this is not detached at all, the mesoderm will not be able to go in between these layers also. So the neural elements will be exposed to the outside environment. Whereas in another scenario, the detachment happening earlier than expected, because it is happening earlier even before closing. So as I told you, this should be a very coordinated manner. The moment it detaches from the ectoderm, it should close. If it is not closing, these mesoderm elements can enter into the spinal canal, and this is called as premature disjunction.